This is day 6 of Advent of Cyber 2025, and this challenge is called Malware Analysis. Egg-xecutable. The town of Wareville remains quiet in the middle of the night. While the residents of Wareville are nicely tucked up in bed, blissfully unaware, the SOC team at the Best Festival Company remain alert, poised and ready for whatever may face them. Monitoring their screens, armed with a freshly poured mug of hot cocoa, the elves of the SOC watch their dashboards diligently. Suddenly, the elves receive an email in unison from Elf McClaws, head of Elf Affairs, in their inboxes. It reads, "To all elves, going forward, we will be using a new program for creating and viewing team routers. This new program will revolutionize how routers are made here at the Best Festival Company. Please contact IT support if you have issues running the program." Why is Elf McClaws working at 3 AM? Screams a member of the SOC team in the background. You're right, something is amiss. Elf McBlue is immediately suspicious. The years of experience in the SOC have given them the wisdom not to download out of the blue executable. Without McSkitty's wisdom, Elf McBlue takes charge. Loading up the malware investigation toolkit, the investigation begins. In today's room will have you taking the place of Elf McBlue, a highly talented member of the Best Festival Company's malware investigation squad. You have been tasked with investigating a highly suspicious executable that's being shared with the company. Today's room will be covering the following: principles of malware analysis, an introduction to sandboxes, static versus dynamic analysis, and the tools of the trade, PE Studio, Procmon, and RegShop. So for today's challenge, there's only a VM that needs to be started up, which will come up in split view like this, or you can connect to it via RDP or SSH with these credentials. Malware analysis is the process of examining a malicious file to understand its functionality, operation, and methods for defense against it. By analyzing a malicious file or application, we can see exactly how it operates, and therefore know how to prevent it. For example, could the malicious file communicate with an attacker's server? We can block that server. Could the malicious file leave traces on the machine? We can use these to determine if the malware has ever infected another machine. Instead of fearing malware, we can take a proactive approach by translating technical findings into practical defensive measures and understanding how the malware fits into an attacker's techniques. There are two main branches of malware analysis: static and dynamic. Static analysis focuses on inspecting a file without executing it, whereas dynamic analysis involves execution. We'll come to this shortly. In cybersecurity, sandboxes are used to execute potentially dangerous code. Think of this as disposable digital playpens. These sandboxes are safe, isolated environments where potentially malicious applications can perform their actions without risking sensitive data or impacting other systems. The use of sandboxes is part of the golden rule in malware analysis. Never run dangerous applications on devices you care about. Most of the time, sandboxes present themselves as virtual machines. Virtual machines are a popular choice for sandboxing because you can control how the system operates and benefit from features such as snapshotting, which allows you to create and restore the machine to various stages of its status. To reiterate, it is imperative to understand that potentially malicious code and applications should only be run in a safe, isolated environment. From now on, this room will refer to the malicious code and applications as samples. These fundamentals covered, let's move on to the practical section of today's room. Following will demonstrate a sample. Must apply these techniques to the hop-helper.exe file presented to you within the hop-helper folder on the desktop of the practical VM. Within the VM here, we can see there's this hop-helper file, and there's hop-helper.exe. So, static analysis. As we alluded to previously in this room, we use static analysis to gather information about a sample without executing it and digging deeper. Static analysis can be a quick and effective way to understand how the sample may operate, as well as how it can be identified. Some of the information that can be gathered from static analysis has been included in the table below. So there are checksums. These checksums are used within cybersecurity to track and catalog files and executables. So for example, you can Google the checksum to see if this has been identified before. So in this example here, the checksum is taking the file and getting a hash of it, and based on the output of the hash, that is used to identify the file. Strings are sequences of readable characters within an executable. This could be, for example, IP addresses, URLs, commands, or even passwords. Imports are a list of libraries and functions that the application depends upon. For example, rather than building everything from scratch, applications will use operating system functions and libraries to interact with the OS. These are useful, especially in Windows, as they allow you to see how the application interacts with the system. So I might be using the createFileW function, which is within a library of the Windows system. Resources contain data such as the icon that is displayed to the user. This is useful to examine, especially since malware might use a Word document icon to trick the user. Additionally, malware itself has been known to hide in this section. However, it's important to note that regardless of how a sample may appear or function, we don't truly know until it's executed. Attackers use techniques such as obfuscation to obscure how the sample appears, primarily to evade antiviruses, but also to evade a curious analyst. So in this section, we'll be using PE Studio on an example called download.exe. So please note that the information you see will be from this demonstration sample. The sample you will be analyzing will be different, but the techniques will still apply. Please note it is imperative that you do not launch the helper.exe executables yet. So we first bring up PE Studio, which is this shortcut right here. So it wants us to then load the executables into PE Studio. Okay, so I think it's using download.exe for the example, but I think we are meant to use hop helper for this. So let's drag and drop that into here. So you can see some information about the hop helper executable here. It's continuing to load some more. So for us at this stage, the file SHA-256 property within the table is of interest. This value is a checksum, which is a unique identifier for the executable. You can keep a note of this SHA-256 as threat intelligence. So proceed to do this on sample hop helper provided to you. Okay, so yeah, we are meant to do hop helper, but we need to find the SHA-256, and that's here foot. I think that's here. Yep, so you've got the SHA-256 here. Let's copy the value. And it's saying it's for answer 1, so let's go down to there, paste that in, and that was correct. Next, we'll proceed with reviewing the strings of the executable. You can do this by clicking on the strings indicator on the left sidebar. So right here, strings. It's loaded up all the string values which have been identified within the executable. In the context of malware analysis, strings are sequences of readable characters present within an executable. This could be IP addresses, URLs commands, or even passwords. As a malware analyst, it's great to have a look at these, as these could reveal the attacker's command infrastructure, which we can use for our defenses. So for question 2, we need to find something within the strings, which might take a little while, as there was 4,000 strings, and most of them are rubbish, but at some point we'll find something. I thought I'd look at what the question was saying. It's saying it's towards the bottom of the strings output, so maybe just go all the way to the bottom. Okay, there we go. Found it right here. Let's copy the value and paste that into here, and we'll continue on. Okay, so now on to dynamic analysis. This section of the room provides a brief introduction to dynamic analysis. As you recall, dynamic analysis involves executing the malicious sample to identify its behaviors and how it interacts with the operating system. Egg-shot is a widely used utility, especially when analyzing malware on Windows. It works by creating 2 snapshots of the registry, one before the malware is run, and another afterwards. The results are then compared to identify any changes. Malware aims to establish persistence, meaning it seeks to run as soon as the device is switched on. A common technique for malware is to add a run key into the registry, which is frequently used to specify which applications are automatically executed when the device is powered on. So before running the malicious sample, we need to create a snapshot of our registry. So it wants us to load up regshot, which if you go to the desktop can be found right here. Click yes for that, and I want to first change the output directory of the capture to the user's desktop. So down here, output path, we will change that to thin ethnic blue. Go to desktop here, do OK, and with that set, let's create our first snapshot by doing this, then shot. So now that we have taken a snapshot of the registry, should proceed with executing the hop helper sample, then take another snapshot. We'll then compare the difference. For you, this is the hop helper executable located in the hop helper folder on the desktop. It's saying that once you've executed the sample, you might see that some strange things have happened. But before we do that, we need to wait for this to regshot to actually complete running before we run the executable. Okay, so the first shot has finished running. So we will now execute hop helper.exe, and we can see it's changing all of our icons to Easter eggs, and a message has popped up saying King Malware sends his regards. So we can assume it's finished running. So we'll now do the second shot and wait until that has finished running. Okay, that's finished running, and now we need to compare the difference from before and after running executable. And that has brought up this notepad, and it has a list of keys, values, keys added, values added, and values modified. One thing we can see straight away is right here is a run hop helper value that has been added. There's other hop helper values have been added, and I assume we will come back to this at a later point. So next, we'll explore using procmon from the sysinternal suite to investigate today's sample. Process Monitor is used to monitor and investigate how processes are interacting with the Windows operating system. It is a powerful tool that allows us to see exactly what a process is doing. So for example, reading and writing registry keys, searching for files, or creating network connections. So open Process Monitor, the shortcut is on our desktop, and procmon will automatically start capturing events of various processes on the system. Let's minimize the notepad, minimize all of this, and right here we have procmon. We will launch, so it's saying now execute hop helper again and return to procmon to see how it interacts with the operating system. We'll see a lot of information, but no need to worry as we will filter it. Procmon open, let's rerun hop helper.exe. So after allowing a minute to pass, ensuring the sample has fully executed, we will now stop capturing this. To stop capturing more events, click on the play button in the toolbar of Process Monitor. So that appears to have finished running. And we will press the play button to stop capturing. As you can see, there is a lot of information to scroll through, with the most recent events at the bottom. Here we can see how various system processes are interacting with Windows. Nearly all of it we don't care about. So it's letting us know that the demonstration is using download.exe while we should be using hop helper. So if we go to filter, brought up this new window, and we want to filter based on the process name. So process name is assume hop helper, name the process, press the add button to apply this filter like this, and click apply, then OK. So maybe doing hop helper like that wasn't the correct thing to do, so we'll go filter again, and let's modify it so hop helper.exe. Now we'll add that back in and apply, and that seems to have being correct, so we can see all the actions that hop helper.exe took on the system. It's much easier to investigate how the process is interacting with the operating system, and here are some operations that may be of interest: reg open key, create file, TCP connect, and TCP receive. However, as you can see, there's still a lot of information. We can further apply filters to look for specific things that we want to investigate, such as these aforementioned operations. To do so, return to the filter heading and create the filter we want to apply. So for example, we can filter by operations. So we can do sort of architecture, we do operation, and we can change is to contains and TCP. There might be multiple different types of operations which consist of TCP. So that's why you do contains, so it captures all of them. We add that in, apply, and we'll now see all operations that include TCP. And we can see there was a connect, send, receive, then disconnect. So that seems to be all for the practical. Now it's time to answer the remaining questions. So what registry value has the hop helper exe modified for persistence? I think that was this one, and my assumption is it's the run one here. So provide the pull path of the key. That would be up to the hop helper. Let's enter that in and check that is correct. Filter the output of procmon for TCP operations. What network protocol is hop helper.exe using to communicate? Going back to procmon, what network protocol? So maybe we can select one of these and look at properties. Okay, we can see it's using HTTP. Add that in, and those are all the questions we needed to answer. So that is day 6 of Advent of Cyber 2025 complete. Like this video, make sure to like and subscribe.